to 0, m raised to 0, right? M raised to 0, again, L raised to what? L raised to, B is equal L raised to 1 by 2 into G raised to minus 1 by 2 we can write. Okay? L raised to 1 by 2 means root L. G raised to minus 1 by 2 means 1 by root G. Therefore, this emptiness is equal to K into M raised to 0 is equal to 1 only. M raised to 0 is 1 only, right? So we can write this equation as L by G. E is equal to K in the root of L by G. So there is a method. With the help of that, we can calculate the value of K. K is found as equal to, that is equal to 2 pi. Hence, the actual relation of T is 2 pi in the root of L by G. In this way, the derivation can be obtained with the help of dimension. See the procedure. First of all, the conditions you will write on which quantities the value depends. This physical quantity depends. In this case, mass, length, and acceleration due to gravity. Then you will write with a constant. This proportionality is changed into equality. So like that, then you will take the dimensions on both sides. Every quantity the dimension is taken. The dimension of mass is m, dimension of length is L, dimension of acceleration gravity is Lt raised to minus 2. Put the powers as shown here. Then you equate the powers of the same quantities on both sides. You can find the value of A, B, C, and then you will put the values of A, B, C on this equation number 1. You will get the equation of the physical quantity. So this is a very important condition, right? Next is centripetal force. One more. This one I am going to write on the board. So this kind of so many questions are given in the textbook. You will go through it and practice it. And we also, so in the this kind of virtual classes, there are a lot of limitations, right? Lots and lots of limitations. So to remedy these limitations, you must also go to the textbook after getting the idea from the videos, and you can do as many as problem. Centripetal force. I'm writing it centripetal force. Centripetal force acting on a particle. Centripetal force capital F acting on a particle moving in a circle may depend on the conditions are given. Depend on mass m, mass of the body m, velocity speed, velocity we can write, velocity v, and radius of the circle, and radius of the circle. Derive formula for centripetal force. Derive formula for centripetal force. Centripetal force. The conditions has to be given, then only we can derive. Conditions are given here. All right. It is already given. What is it? That means centripetal force. Any body moves in a circular path. For example, Earth is moving around the sun in a circular path. Elliptical path is a case of circle only. So anytime there is a centripetal force is acting, that centripetal force, due to the centripetal force only, there is always moving in the circular path. Right? This is a uniform circular motion the Earth is executing. So Earth, when completes one revolution, it takes a certain amount of time. Every time it completes one revolution, it takes a fixed amount of time. That is called time period of revolution. Right? So you see, when a body is moving in a circular path, always there is a force acting. Suppose this is a body, and this is another body moving around it. There is a force always acting towards it. This is a small mass, and this is a big mass. So between the big mass and the small mass, there is a force acting, and that force only keeping the body in the circular path always, right? And this force is called a centripetal force. So any body revolving with respect to any other body, right, with a uniform velocity, always there is a force acting on the body which is revolving. That force is what is called centripetal force. Right? In this case, what are the factors on which the centripetal force depend? That is given here. So you will write first F is directly proportional to, which are the mass, m raised to a you will write. Next is velocity. Velocity means v raised to b will write. Then is what? Radius. Radius raised to c you will write. This is the first way. Next you will write this is equal to a constant k into m raised to a, v raised to b, and r raised to c you will write. Remember, k is a constant that has no unit. Am I correct? So what we can write is, now we put the, write the dimensions of all the quantities. This quantity, this quantity, this quantity, this quantity. Separately you will write. This is force. Force means m, l, t raised to minus 2. That everybody knows that force is equal to, the dimensions of force is equal to m, l, t raised to minus 2. A has no dimension. M means capital A, the whole raised to A you will write. V means velocity. Velocity everybody knows that is L T raised to minus 1 raised to B you will write. Radius is a length only, therefore radius is L raised to C you will write. So this is the condition. Yeah, you got. Am I correct? Am I correct? Okay. Now what do you do? This has to be distributed. That is, this is M raised to A. Here what do you write? L raised to B and T raised to minus D you will. Into again L raised to C you will write. Here also two similar quantities are there, L raised to B and L raised to C. In this case, we can write M raised to A, M raised to A into what? L raised to B plus C you will write. B plus C. Same thing, A raised to M into A raised to N is equal to A raised to M plus N. Right? Again into T raised to minus B you will write. So this also obtained. It had no dimensions. Now equating the powers. Powers equated means this side M and this side also M. This M has its power is equal to 1. This L has power is equal to 1. And T has power is equal to minus 2. Here M is equal to 1 you can write. Sorry, A is equal to 1 you can write. So here you can write A is equal to 1 you write. Next, B plus C is equal to 1 you wrote. Right? Last, what is that? Minus B is equal to minus 2 you will write. Minus B is equal to minus 2. Therefore, B is equal to what? B is equal to 2 only. Applying this formula, what you'll get? That is, B means 2 plus C is equal to 1. Therefore, C is equal to 1 minus 2. 1 minus 2 is equal to what? 1 minus 2 is equal to minus 1 you will write. Right? So, A is equal to 1, B is equal to 2, and the C is equal to minus 1 you got. Applying this formula, you will get the relation. Very readily, you will get the relation. Now, F is equal to K into M raised to 1. K into M raised to 1 into what? B raised to 2 now. That means that is equal to into V raised to 2 into R raised to minus 1. R raised to minus 1, right? R raised to minus 1 you got. So how can you write in a decent way? This is equal to K into mv square by R. K into mv because R raised to minus 1. R raised to minus 1 is equal to what? 1 by R. So actually K, the value is found as equal to 1. K, we can find this value of K is equal to 1. Then F can see F is equal to mv square by R. In the later stage, when you study physics in class 11, you will find this relation. This is a very important relation. What do you call? The centripetal force acting on a body which is moving in a circular path around another body, or anywhere the body which is revolving around, right? You are you hold one end of a string and other end of the string a body is tied up and it is rotated in a circular path. Circular, you will feel some kind of force at your fingers. This is centripetal force. Centripetal force is the radial force. It is acting along the radius toward the center. A force which is acting along the radius toward the center is called a centripetal force. The expression of centripetal force is given by F is equal to mv square by r, right? So this is about centripetal force. So this chapter is over. Now, one problem is described in the notes that also you can go through it, or you can find as many as problems from the textbook, right? So once you have learned the things means you can work with that formula and everything and the method how it is that you know. Now you can read out and you can collect as many as questions from the reference book, and you do as many as questions as you can. Right? There is no limit for that. This is the lesson about. Tomorrow I will come with a new lesson. Till then, bye bye.